Thank you. Thank you so much for the warm welcome. Just before I get started, I wanted to ask you all, if you haven't already done so, to download the app and rate this session, but rate all of the sessions, because speakers really, really appreciate any feedback you can give them, because we want you guys to enjoy and get something out of this time with us. So thank you for the introduction. I guess there goes my first slide, right? So just to sort of go quickly through this, I did join the Java group in 1996. At that time, the group was actually a separate little startup. It wasn't really part of Sun. It was separate. We were actually located across the street from the Apple Infinite Loop headquarters in Cupertino. And we used to sort of look across the street and wonder when they were going to go bankrupt. So, we weren't all that good at predicting the future of business, but, maybe we could be good at technology, right? So I kept working there for a while. I worked separately at BEA on JRocket, and then ended up in Oracle that way. And when Oracle acquired Sun, was asked to sort of move from Sweden back to the US and put the two groups together and make sort of the future of Java be the best of both worlds. And so that's what I've been working on since then. I am also the chair of the OpenJDK Governing Board. So what's that about? Well, its function is to ensure smooth and effective operation of the community that is working on the most popular open source code base for Java. And that is the code base on which the Oracle JDK is built, as well as several other very popular distributions. So in those roles, I've kind of had a front row seat for many of the changes in the Java ecosystem. Now, most of these have actually happened since I was last here at YOW, which was in 2015. And today I'm going to talk about some of the things that we're bringing in Java 21, which came out a couple of months ago, but also hopefully give you some insight into how we think about Java evolution. What do we prioritize working on, and how have we adjusted our methodology to be able to bring you those things more quickly? Okay, so in 2015, we had just delivered Java 8, and we were working very hard on 9. It was kind of a couple of years out there on the horizon. And now's probably a good time to ask you which versions of Java you're using. So first of all, an easy one, how many people are using mostly Java 8? Okay, a few hands. Actually, not that many. That's good, probably. Okay, how about Java 11? All right, a few more. How about 17? All right, I think 17's got it thus far, but now we're going to go full bore here. 21 or newer? All right, a few. Well, that's good. You're ahead of the curve. You're also a speaker, so that's bad. Okay. So, all right, now we're going to do the tough one, which is, does anyone want to confess to running something prior to Java 8? All right, I think there's a security talk for you down the hall. No, it's okay, you're not alone. I'm sure there are a lot of people in the same boat, and there are some good reasons for it, although I would encourage you to upgrade to something that is currently supported by someone. Okay, so, so let's see. Back in 2015, there's one more. How many are wondering what the heck I'm talking about, why I chose those numbers, because they seem kind of random? All right, we got a couple of people there. Well, all will be revealed, don't worry. And the rest of you, I'll try not to duplicate too much stuff. All right, so back in 2015, the model that we had for Java releases had really been the same since the very beginning of Java time. They were big bang releases. They were feature driven. So we would decide, years in advance, this is what's going to be in the next release, and then we would work really hard on it and hope that it didn't take longer than we thought it was going to. And we all know how that goes, right? The software industry has evolved a lot since the mid-90s, and we've learned a lot about making software. And we've learned that that's generally not a very good way. Because they were feature-driven, they often took longer than predicted. Because there was already a long time between releases, the incentive for developers was to take the thing they had, the feature that was not quite done, but almost, and sort of shove it in. Because the stabilization time is pretty long anyway, right? Guess what makes the stabilization time even longer? When you shove a bunch of stuff in that's not really done yet. So that tended to make it so that those features came out not quite ready. It took a long time for people to adopt new versions. It took a long and importantly unpredictable amount of time between releases, and that's no good for anyone. It's not good for people who want to use Java. It's not good for enterprises. It's not good for the developers of Java itself. It's pretty much horrible all around. So, oh, and the other thing that does is it sort of increases the desire that people have to say, well, it's going to be like years till I can use that feature in the new version. Couldn't you just put it back into the old one for me? Backport, yeah. Guess what makes those versions that people are trying to use really unstable? When you try to backport big features. Okay, so that was a mess. So we decided we needed to do something about that. We wanted to have a way to get features into people's hands earlier and more quickly. But this was not just about the convenience of the developers of Java. We talked with the people who were using it. We talked with developers, we talked with enterprises, and we saw that those were kind of the two groups that the answers clearly boiled down into in terms of what they wanted. There tended to be a lot of developers who were like, give me new features, give them to me now, I can't wait, I want it today, I want it yesterday. And there were enterprises who were like, Java 8 is perfect. Don't add anything. Whatever you do, don't touch it. It works, right? Okay. Now, so the funny part of that story is when you go and talk with the people in the enterprises who say that, and you ask them, oh, Java 8's perfect, that's awesome. So tell me what you're using for your next project. You know what they said? Node. Yeah. Well, okay, so their point was it's perfect for me for that application. It wasn't perfect for them in terms of decision making for what they wanted to invest in and use going forward. And of course, we were kind of biased. We wanted them to use Java going forward. So that was not a complete answer. So what did we do? Well, we decided that we were going to change this around. And what we decided to do was say, look, a big part of the problem here is the feature-driven model. So we're going to try to move to a time-based model where basically we're going to do a new release on a very, very specific cadence. And we're going to make that cadence be short enough that if I miss this release, I'm not that worried about it because there's another one right around the corner. So basically we decided on 6 months. And basically, everyone, yeah. So that's great for the new features, but what about those enterprises that never want anything to change? Well, we decided to augment this with taking one of those releases every couple of years. We actually started out with 3 and now we're on 2, where we said we're going to take a particular release line and we're going to use that just to backport security, stability, and performance fixes. No new features. We're not going to get into that game, but we're going to keep you secure. So if you've got something that's up and running, make sure you're on one of those releases and you'll be able to stay on that for years and years and years and years. And so that was kind of the compromise that we came up with. And I talked with people in the group, I talked with people in the ecosystem, I talked with customers, and by and large, they all thought I was crazy, right? Lots of skepticism. So why were people skeptical? Well, the people who were working on Java were skeptical because we'd never done a release this fast before. They knew that there was a lot of overhead in what we did and a lot of technical challenges. They were also worried that we might actually not have any features. Like, well, what if there's nothing new? Are we going to do a release with nothing in it? They were worried that we were going to be overwhelmed by backports. And these were all very, very rational things to be worried about. But what they basically boiled down to was they were afraid of change. This was something different. It was scary. When I talked to people in the Java ecosystem, they said, Java 8 is all we ever need. They also said, gosh, this sounds like we're going to get a whole bunch of releases. That sounds really scary. And they were worried that the quality would suffer, right? That with so many releases, we couldn't possibly keep Java at the level of quality that it was known for. Okay, those concerns also basically boil down to we're afraid of change. It's different. We don't know how it's going to work. Okay, these were some of the comments that people posted publicly at the time. And this is not just anyone. These are like known, famous people in the industry. So yeah, this thing, I've got it on good authority. It's utter bullshit. It's never going to work. These guys are crazy. They're kidding themselves. All right, well, I will say that the changes that we needed to make in order to make this possible were not just technical. There were technical challenges, sure. We needed to redo the way that we built and tested Java. We needed to actually version our tests with the code, which we weren't doing before, for actually good reasons, but like that didn't work. And the main thing that we needed to do was sort of unlearn a bunch about, of the things that we knew about how this worked. So this was not really a technical change, it was a cultural change. It was a change in mindset. And the big change in mindset was realizing that, okay, my feature's not quite done. I'd rather be the first person in the next release than the last thing shoved into this release that's about to go out. And so it was really about getting people to the point where they felt that they had all of the automation and all of the testing to make sure that something was done and ready before they checked it into the mainline, destined for the next release, but also that it was okay to miss a train. The other thing that came along with that was this sort of notion that everything needed to be backported. The team, because it was so long between major releases, was kind of in the habit of backporting just about everything they could. And what they needed to do was sort of change the mindset to say, you know what, I really only want to backport something if it's absolutely necessary for a customer running today on that version. And that mostly boiled down to security fixes. Okay, so one other interesting thing, the features that we had done before to date had all been these, pretty large, pretty significant features. And the thought at the time was, well, it's very, very hard to break those down into smaller features. And so this was a sort of new skill that people needed to learn, right? How do I take a big, massive feature that might take 2 years to do and think through, are there ways that I can deliver parts of it more quickly? I'm going to mention one more thing as I get to here, the payoff, which is doing unpredictable releases is very expensive. You have a lot of overhead, a lot of process, a lot of meetings where you discuss whether something that should go in or not, whether you should move a date or not. One date moving means that other dates move. It is really, really, really expensive. And so, what we ended up finding was by having a regular cadence, knowing when it was, not needing to replan, we could actually reuse all of the process from release to release and just get better and better at this over time. And so we ended up with developers of the JDK spending far less time in these meetings that they didn't want to be in anyway, and far more time focusing on developing the next features that they wanted to bring to you. So this was pretty cool. At first people were skeptical, but after we kept doing them and delivering, and people saw that features were coming out, and they were coming out regularly, and the releases were coming out regularly, and they had less overhead, they kind of started to like it. And so after a couple of years, I visited one of my teams in actually Burlington, Massachusetts, and somebody pulled me aside and said, hey, I never thought this was going to work, but it's awesome. This is so good, I would never want to go back to how we were doing things before, and thank you so much for making it happen. And not only did the people on the team say that, but people in the industry said it too. So these are all actually from earlier this year. And as you can see, everyone is happy, right? Well, in an ecosystem the size of Java's, not everyone is always going to be happy. There's always going to be someone who is missing something. Okay, cool, that's good. All right, so here's just a very quick visualization of the way the model is today. Right, there's tip development that's done. All of our new stuff goes into the tip. And then every couple of years, something is designated as a release that's going to get long-term support, and that it will get for years and years and years. And what this means is that developers are getting the features that they want quickly, and the enterprises that just want stability can just kind of squint at this and say, I'm just going to pretend I just look at the LTS ones. And the model actually looks like it did before, right? With the difference that it's just a lot more predictable. Okay, so did we find a way of doing 3 years of work in 6 months? No, of course not, right? Each of these 6-month releases is a lot smaller, and that's good, right? In the industry now, we think that lots of increments of smaller amounts of change is a good thing. It makes it easier for us to adopt. And then, if we look back since 17, so 21 is due for long-term support, 17 has long-term support, and 11 has long-term support. And so interestingly, what we found, we wondered whether there was going to be sort of a trade-off between throughput and latency. And it turned out that with this model, we actually didn't trade off a whole lot of throughput. We were still getting a lot of features coming in. It's just that the latency was far, far better. One other thing I'm going to mention here, and this was something that we didn't even realize we would get out of this model, is the ability to designate features as preview. Now, what does preview mean? Does it mean it's a beta? It's actually not, right? In the past, a preview feature, we would have said it was final, and we wouldn't have been able to change it for the next 30 years. And it would have probably not been quite as good as it could be if we could put it out as a preview, give you a flag to turn it on, and then get feedback from people using it in all kinds of cases that there's no way we could know about or test, so that any sort of last bits that needed to be nailed down or adjusted to be good could actually still be done. So you should think of a preview feature as just like a final feature, except the concrete's not poured. And we want to and do hear from people about their feedback on it that has informed the final version. So generally now, things that come in, especially in the language, we tend to go through a couple of rounds of preview just to make sure that it's really solid before we pour the concrete. Okay. So that list of features that I showed you may have looked like sort of a random grab bag of things. And so a very reasonable thing to wonder about would be, how do we decide what features we're going to work on? Is it just random? Hopefully not. What we try to do is talk with our users and understand their pain points today, right? What are the things that are difficult for them or that are causing them angst? And we also try to look at the trends in programming models. So how do people want to write programs today? What are architectural shifts that are popular? And we also look at the direction that hardware is evolving. Because one of the things we've always tried to do with Java is make sure that your existing Java programs can take advantage of advancements in hardware without your having to rewrite everything. So we also look at other platforms to see what's been successful. We try to understand why and how what we learn from that could apply to Java. We look also at shortcomings and try to think about how to address them, but we want to address them in a way that doesn't feel bolted on. We want it to feel like a natural part of the evolution of Java. So, we don't try to necessarily solve point problems, rather we try to provide platform capabilities that fosters an ecosystem of alternatives solving those. And that all kind of boils down to, we try to triangulate and figure out, God, I don't know if there's an Aussie rules thing for this, but in hockey, like this works great in Canada, we try to skate to where the puck will be, right? So this is basically figuring out where's everything headed, how can we make sure that when you need it, Java has it. And we have a few years of being behind to catch up for, but I think it's going pretty well with this new model. So let's go ahead and look at some of those features, right? So these are things that have been brought through this model. And the first one I want to talk about is, I think, really the biggest news of Java 21, which is that Project Loom and virtual threads have gone final. And so I think that Loom is going to be, for 21, what Lambda was for 8, right? It was, the big feature that everyone wanted, had been waiting for, and now that it's finally there, there's a mass movement to adopt it. So what does Loom do? Well, it basically takes Java concurrency to the next level by barely changing it at all. And why do we do it in the first place? Well, we don't want people to have to choose between doing efficient development and actually having very scalable deployment. Well, what do I mean by that? Okay, well, threads are great, right? They've been a strength of Java from the very beginning, kind of baked into the language and the platform. They give you great debugging, great serviceability. You can write synchronous code that's pretty easy to understand. You have comprehensible stack traces, but threads are really heavyweight. And the reason they're heavyweight is that from the beginning, Java had a one-to-one mapping of a Java thread to a native operating system thread. And so you can very easily run into the ceiling there. Now, lots of people will talk about techniques for moving past that. There was a whole movement around async or reactive programming that basically is to try to address exactly that. The problem is that when you move to a model like that, you have to rethink how you're doing everything. And you lose a lot of the clarity of code, the maintainability of code, the debuggability of code. And so what we did was we came up with virtual threads in Project Loom. So from a user perspective, Loom basically has no new APIs. The main new runtime construct is virtual threads, which basically share today's thread API and semantics. But they're implemented completely differently from existing platform threads. Rather than being tied to an OS thread and carrying around a big contiguous stack, virtual threads store their stacks in the heap in the form of delimited continuations. So a virtual thread has a couple of hundred bytes of metadata, starts up much faster than a platform thread, and uses only as much stack space as is actually needed for active stack frames. And as a result, we can create many, many, many more virtual threads than native platform threads. So, basically what that boils down to is, Loom just makes threads lighter, right? Now, that seems like one of those obvious things, right? Like, hey, you want to make your programs better? Just like write them with no bugs. Okay, you just make threads lighter. That sounds really easy, right? And we know it's probably a lot harder than that. And it is, but I think with virtual threads, we've actually pulled it off. Basically, virtual threads are real threads. They implement Java lang thread, they support thread locals, and they have all of these properties that we were looking for. And so you can kind of think of them as threads without the baggage, and the move from using existing heavyweight Java threads to virtual threads is, in most cases, really, really simple. So what does that give you? Well, here you can see an example of a server that's basically running an IO-bound workload. And so, at some point you're going to run out of threads, and your ability to handle more transactions is capped, and your latency skyrockets. So in this example, you see a couple of different plots. One of them is running a thread pool with a limit of 200 platform threads. So it kind of goes along, it's doing great, and then boom, it hits 200, and now your latency is through the roof. So, how do you fix that? Well, the obvious way is to say, I'll just increase the size of my thread pool. That's cool. So now I'm going to go along. I've got one that's a thread pool that's up to 800 threads, and I'm happily, processing stuff. And now I get to 800, and boom, my latency is horrible again. And so we could just keep playing this game and increasing the number of threads. The problem is at some point we're going to run out of operating system threads, and that is going to be the end, whether or not we've actually saturated the CPU. In fact, we probably haven't. Right? So this is sort of an artificial cap on the scalability of your system. With virtual threads, you don't run into this issue. You can just keep going as long as there's CPU to keep up. Okay? And just to show you, the virtual threads line is on there. It's the green line that goes all the way across the bottom. Right? Now, that eventually will go up, but it's probably somewhere on the other side of the next room. Right? Or further. So that's kind of cool. So the trick here was basically to have the same abstraction but a different mindset of how to implement it. That greatly simplifies writing, debugging, and maintaining code, but it doesn't come completely for free. You do need to unlearn some tricks that were employed in the past for scalability, such as thread pools. You really want to think of a task per thread and kind of go forward with that. And one group that has done that and already moved to this is the Helidon folks, who had done a bunch of stuff that was basically based on Netty, that was async. And they went back and re-implemented on top of virtual threads and basically found that they got, in just a very small amount of time, they were able to get exactly the kind of throughput and latency that they had before, that they had been working on for years, but with far, far, far simpler code. So, this is what success looked like for them, is they had a bunch of complex code that they threw out the window, and now they're happily going along with the simpler model on Java 21. Okay, so what's another feature? I'm going to talk about garbage collection. So ZGC was introduced in Java 15, and it supports sub-millisecond pauses that don't scale up with the heap size or the number of live objects. Now, not scaling there is good, right? You want it to kind of stay the same as you're dealing with a lot more information. We call this ultra-low latency. It means that you no longer have to worry about GC pauses. So where G1 is partially concurrent, ZGC is fully concurrent, all of the accounting work of moving objects and updating pointers is done concurrently with the application. The very brief pauses are just sync points where GC threads coordinate their activities. Now, the catch is there is a reduction in throughput, partly due to the presence of GC threads doing concurrent collections, and partly due to ZGC having a higher footprint that means less memory for the application to process requests. But as you can see, it's in most cases a pretty small reduction in throughput in order to get this. And what is it that you get? Well, here you can see a graph, and you can see for G1 at various percentiles how it's doing. And those pauses look not bad. We've got up to it at max somewhere under 450 milliseconds. Now you want me to click the button and add the graph on ZGC, right? Except I can't because it's already there. All right, let me show you what I mean. Okay, so this is a chart in milliseconds. So first we need to go ahead and go to microseconds. And then we're going to zoom in and look at ZGC. Oh, hi, Duke. And there you go. There's the ZGC graph. So that's pretty awesome. It's really, really cool. And again, it's the kind of thing that you can try out, not necessarily for every application, but if you care a lot about latency and you don't want to give up a lot of throughput, give it a try. So new in Java 21 is we've added a generational capability. This is something that we did because basically we didn't want you to also have a lot higher footprint. And so basically we were able to find that we got tremendous reduction in throughput with the generational capability on Java 21 on a real life case using Cassandra. So again, I hope you'll try it out. So lest you think that we're just working on this new shiny garbage collector and we don't care about the existing ones, this sort of gives you an idea of some of the other work that we've been doing in parallel on other garbage collectors. So they have continued to improve as well. And the reason for that is we don't think the garbage collection technology is yet at the point where there's one size that fits all. We think that it does make sense for you to look at it and choose what's right for your particular workload. Okay, next interesting feature, I'm going to talk about Project Panama. Let me ask first, how many people have had to write Java code that is calling to native or the other way around? Okay, I'm so sorry. I'm really sorry. And the reason I'm sorry is that when we were originally writing JNI and adding the capability to call from Java to native, people were frankly afraid that that's like all people were going to do, right? They weren't actually going to write any Java programs. They were just going to call out to native. So let's make it really hard. And they succeeded. Like JNI is a pain to use. It's a pain to maintain. The performance isn't great. I can tell you I have in my group some folks who do support for customers, and it is way overrepresented, the number of bugs that come in that are basically bugs where people have tried to call out to native in JNI and have problems caused by that. So we decided that now there's enough Java out there in the world that we could actually make this easy and convenient for people. And there are lots of good reasons, right? There are lots of reasons you might want to call native. There's lots of great libraries out there. We've seen lots of techniques that have been used. For instance, machine learning in Python is mostly just calling out to a library in another language. And so we felt that Java was at a disadvantage not having a good capability for that, and we decided to do something about it. This was a few years ago, and the result of that work is Project Panama. And so let's go ahead and look at this. Basically, there are kind of two things that it really covers. And I should mention, it's already final, but it's final in 22. So basically, it allows you to combine Java and native code. It also allows you to manage off-heap memory. And so that we think is going to make things a lot better for people. As a side effect, it's also going to allow us eventually to get rid of sunmisc unsafe, which is, if, in case the name doesn't make it clear, is unsafe. Okay. So basically, this is sort of the goal, is to give a better and performant alternative, final in 22. It has been in preview actually for quite a while. So you've been able to use it, you've been able to try it out, and people have done that and given us lots of feedback. So I think this is something that a lot of, not everyone is going to use it, but people who have this need, I think are really going to appreciate the capabilities that it brings. All right, I'm going to mention Project Amber just kind of briefly. This is a project that is really about trying to sort of right-size ceremony in the Java language. I'm going to give a particular example in a moment, but this is to give you a little bit of an idea of this notion I was talking about of breaking larger features down into smaller ones. So in the past, we would have looked at this and said, we want to add pattern matching to Java. And we would have thought of all of the places we wanted to add pattern matching to Java, and we would have tried to work through all of them, and it would have taken years, and they would have come in, and it would have turned out that we got something slightly wrong, and everyone would hate it. And instead, what we've been able to do is take simple examples, start to build on those, get feedback, see how they work, and try to make sure that as we're adding it throughout the language, it is something that is coherent and really solves the need that people have. And again, this is not something where we started out and said, pattern matching is cool, let's add that. It really was kind of the other way around. We started from the perspective of people more and more want to do data-oriented programming, right? When Java came out in the mid-90s, we were just coming off of using that cool small talk stuff, right? Like everything's objects, well, except primitives, because something has to be fast. And we wanted to get to a point where that power of objects was everywhere. And we added things to the language like serialization, dare I say it, where you could ship objects back and forth between processes. Okay, well that's great, it's powerful, it's useful for some things, but it turns out that's not mostly what people want to do. What people mostly want to do is something like JSON, right? It's like take some immutable data from over here, ship it over there, be able to take it into its component parts, build it back up again, and not have security bugs in the meantime. And so that's kind of where we've been headed, is with the ability to handle that kind of immutable data in large amounts and reason over it in a very, very performant way on modern hardware architectures. So all of those things from Amber, or most of them, are really kind of from that. Okay, next area, Java in the small. Well, what do I mean by that? Most of the features that we've looked at thus far have been improvements that have helped experienced developers solve really complex problems. But Java isn't just intended to be for the most complex cases. In fact, when it got started, we were kind of compared with things like C++, and we were called like a toy language for bouncing heads in browsers, right? If you don't know that reference, look it up. So as time has marched on, other languages have sprung up or actually become better at offering a simpler model for programmers to get started. And we wanted to kind of learn from that. So I'd encourage you, if you haven't, to check out the white paper, Paving the On-Ramp, which goes through some of the work that we've done and intend to do here. And I think one thing to keep in mind is our intent is not to have a simple mode and an advanced mode. It's really that they all be valid Java, but that you be able to start with something simple and build up to something more complex as you learn. So I'm going to give you kind of an example here, right? Most people who learn Java don't have a good time. Their first hello world program is full of boilerplate that makes them think, oh my God, Java is hard, right? And more than boilerplate, it's full of concepts. They're concepts that the students aren't really ready for, so the teacher has to say, well, just never mind that, you'll understand it later, right? I see a lot of you kind of nodding in recognition, yeah, I remember that. Okay, well, 90% of everyone's first program is kind of about concepts that are designed for professionals who build large applications. You've got things like classes, static methods, arrays, access control, static fields, and that list kind of goes on and on, right? And we actually think that the on-ramp for Java can be made a lot smoother by taking some of those unnecessary concepts away. So the first thing we can take away in this very, very simple program is the arguments. Right? If you're not going to use command line arguments, do you really need to have the string array? No. All right, so we take that away. If you only have one class, do you really need to have access controls to talk about which other classes can invoke your methods? No, you don't need that either. What about static? Okay, well, you don't need static at this point. The compiler can figure out that this class has an accessible public constructor, a main method, and do the right thing to get main running. Well, system.out.println is probably the most common utterance in your first 100 programs. Do we need to make you jump through hoops every time you want to do that? No. In fact, we don't even need to make you declare the class. This code is probably in a file called helloworld.java, so the compiler can just make up a class based on that name. So all you really need are some statements and some methods to print something on screen. Paving the on-ramp is about altering the Java language so that this program is legal. And it might seem like this is a war on boilerplate, but it's really not. Simple programs should be simple and kind of build up to object-oriented concepts when students are ready. We think one of the reasons why people teach Python as a first language today is because students can be writing their first program in like 30 seconds. And the concepts can be introduced incrementally. So we want to help educators teach Java in a similar way. Now, learning a new language is not necessarily just about the language itself and the syntax, it's also about the tools. And one of the trends we've seen in education has been towards lighter weight, more accessible IDEs such as VS Code. We took a look at the Java support in VS Code, and frankly, we were kind of disappointed. And found that a bunch of the work that we had done on NetBeans in the past to make it use the Java-C compiler directly out of the box could be reused here. And so we put together and have put out a plugin for VS Code that's based on the NetBeans LSP and Java-C from the Oracle JDK. So try it out. It's pretty good. And the nice thing about that is anytime we add something, it's immediately available. And to make things even less friction to try out new versions of Java, we also added a playground to the dev.java site, which is a site that we have for, basically for developers, right? This is what everyone thinks java.com should be, but it's not for historical reasons. So if you haven't checked out dev.java, check it out, and especially check out the playground. This actually uses Oracle functions in the back end to take whatever you're typing and send it off and execute it and give you the feedback. So it's like a REPL. It's all built on JShell, which is in the JDK, using the APIs that we have. Okay, so I talked a bunch about features. Now I'm going to talk about seatbelts. All right, that's weird. Okay, let me explain. When I was a kid, seatbelt use was not required in the US. Regulations, came after, when I was kind of in my teens, and, basically most people, took it as kind of a helpful nudge to do what they already knew was really a good idea. But there was sort of a vocal minority who chose instead to complain about governmental overreach, the intrusion on personal freedoms. Okay, well, 30 years later, like most people now wear their seatbelts and highway fatalities are way down, right? So when we did modularity in Java 9, we described it as a seatbelt, not a jetpack. Now, a lot of people kind of looked at this and like the analogy was lost because they were like, I don't see any jetpacks, what's he talking about, right? So, strapping yourself in when there's nothing you're going to get from it and you're not moving very fast kind of seems unappealing, right? Well, the seatbelt, a project jigsaw, that internals can be kept internal is not there because we wanted to wag our fingers and say, you're doing bad things. It's there because we wanted to move faster. We wanted to bring you jetpacks. In the early days of Java, most boundaries such as access control were more like suggestions, right? Libraries did some very cool things with this flexibility, but it didn't take long before that started to be a real drag on our ability to actually evolve Java and make it better for you. And in fact, those use of internal APIs became sort of de facto supported APIs. We couldn't make changes to them or things would break. And in the 6, 7, 8 timeframe, this has become a real drag on our ability to evolve the platform. Luckily, we've left that in the past. The rapid pace of innovation you're seeing today is the jetpack. Project Loom is the jetpack. ZGC is the jetpack. And so it's nice to think that we can have jetpacks without seatbelts, but the reality is there's no way we could have delivered these jetpacks so quickly and reliably without the seatbelts. So by writing in Java today, your application gets a steady stream of improvements tomorrow, delivered incrementally and compatibly. You can upgrade to Java 21 and get the benefits of ZGC with no code changes, or of Loom with minimal code changes. That is, if you can upgrade. So I hear you thinking, wait a minute, hold on, Java's all about compatibility. What's the problem here? Well, the problem is almost always about dependencies, and often indirect dependencies, right? So it's not that you've written something that's bad, it's that you're using a library that's using a library that has chosen to take liberties, and now it's hard for you to upgrade. So most libraries don't have any trouble upgrading to the latest JDK, but a small number can't because they're dependent on unsupported platform internals. Unfortunately, it just takes one of those dependencies to make it so that the entire application can't be upgraded. And that might be one you don't even know about, which just came along as a dependency of something else. So the good news is that the jetpacks will keep coming, but we have a challenge ahead of us, one which we have to navigate kind of together as a community, which is how to manage the transition to universal seatbelt use. So when we've done that, we can all get to ride the jetpack safely. The challenge here is that applications are seeing in upgrading to 17 or 21. It comes from a small fraction of libraries. They're using APIs that are restricted or removed even in later JDK versions. Now, we don't remove things gratuitously, and when we do, there's almost a supported alternative. We saw an example earlier with Panama where off-heap memory management that people currently do with unsafe is being replaced by a better and safer alternative. But replacing something better, replacing something with a better something, it should be a good thing. But sometimes it puts libraries that use those things into a bind because they have a hard time supporting both the new way and the old way. And so that's a bit of a challenge. I believe that the answer to that challenge is if more libraries learn from what we did successfully on the JDK and embrace a similar model. If libraries develop with a tip and tail method, they can both support their users who are using an existing LTS version and also support the new things that are coming. So that's really what I'm hoping we're going to see. And if there are any library maintainers in the audience, come hit me up after the talk and we'll talk about it. Now, I imagine that if there are library maintainers, you're skeptical about this, you think it's going to be hard, you think it's going to be expensive, and I would just kind of encourage you to think about the fact that we thought that too. And it turned out to be the opposite. It turned out to be the best thing that we ever did for being able to continue to improve Java. All right, now the sort of lesson on seatbelts is over, and we'll get back to something fun, which is what's another jetpack that's coming? And here I want to mention Project Leyden. So Project Leyden is about improving startup and warm-up of Java applications. For long-running applications, might not matter. But for some applications or architectural patterns that are very popular, it well could. And in any event, I've never had a developer who came to me and said, I wish my program took longer to start up and reach peak performance, right? So I think one thing that's worth thinking about is there's a lot that goes on in Java applications and in the runtime as a part of application startup. Everyone knows that Java is a statically typed language, and that brings a lot of advantages. But Java also has a tremendous amount of dynamism, and that brings a different set of advantages that we all benefit from. But that dynamism comes often at the cost of slower startup and warm-up. As always, we're looking at ways to give you the best of both worlds and make improvements to both of those without making you give up dynamism. But we're also looking at what kind of trade-offs can be made where you might be willing to give up a little bit of dynamism in favor of better startup and warm-up. So that is basically what Project Leyden is about. right, is if we look at the curve here, you can see the startup phase, you see the warm-up phase, that's in the yellow, and the ideal would be this sort of green line at the bottom. We've done a bunch of work, I'm happy to say, and the result of that work I'm going to show you a couple of slides on here. The way that this works is looking at things that can be shifted from startup time or warm-up time, either later by doing it lazily when it's needed, or doing it earlier, for instance, at build or deploy time. And these are actually tricks that Java has done for years. It's just that we've really been looking at how far we can push the envelope on that. So with the work done thus far, one thing that we've tried it with is Java C, which it turns out is a very, very popular Java program that lots of people run. And the red line that you see there represents the improvement to startup. So it's about a 2x startup improvement, and also to warm up. And that's basically with just about under 6 months of work on Leyden thus far. Now that looks great, but Java C is a small program. What about something a little more real? Well, we decided we would look at Spring Boot, which is a little bit larger, and they have an example program which is called Pet Clinic. And basically what we found was that the work shifting from Leyden was combined with the condenser that the Spring team had already done themselves, and basically that resulted in about a 4x startup improvement. So pretty cool, very exciting jetpack to come. I don't know about you, but that's the kind of jetpack I'm really excited to see. With that, I wanted to say thank you for coming. Do we have time for questions, or are we gonna?
We do have time for questions.
Okay.
There's hands up.